In exercise 6.2.26 in MyLabs Plus, we're basically asked to construct a confidence interval to estimate a population mean. And the level of confidence that's given later in this question is 95%. So the question the student is asking is, how do I use technology to help me with this confidence interval? Well, we know that a confidence interval for a population mean, when we do not know the standard deviation of the population, so rather have to use the standard deviation of the sample as an estimate of it, is found using the following formula. And so first, how do we go about determining x bar, determining s, and then finally, how do we go about determining the critical value t star or t sub c? Well, if we've got a TI-83 or TI-84 calculator, this can be done quite quickly by entering the data in a list. So go to Stat, Edit, and enter all of these numbers in a list, and as you'll see in the following screenshot. And then calculating the statistics with regards to the data values that have been entered in that list. And we can do that by going to Stat, Calculate, One Variable Statistics, as you'll see in the following screenshot. Now when you enter that command, stat calc one variable statistics, you may or may not, depending upon your operating system, need to tell it that you're wanting the one variable statistics for L1. If your calculator requires that, L1 can be found as a second function key, second one. So there's our x bar, there's our s. Now the only thing we are in need of now is what is that critical value, that t sub c or t star? Well, what we're going to need to do is we're going to need to envision that we're in this t distribution. We're trying to capture the middle 95% of that distribution. That means we're leaving out 5%, half of which is in this lower tail, and the other half is in the upper tail. So half of 5% is 2.5%. So what we're going to do is we're going to tell our calculator to find the critical value, t sub c. And to do that, we need to say, all right, give me the number of standard deviations above the mean that I need to go in order to capture the lower 97.5%. Where does the 97.5% come from? Well, there's 95% below that critical value plus the additional 2.5% in the tail, giving us a total of 95 plus 2.5%, which is 97.5%. So we're going to go ahead and we're going to use the inverse t command. Now if your calculator doesn't have that, then you're going to have to use the table of critical values for the t distribution. But if your calculator does have the inverse t, you're going to go to Second Variables and choose inverse t, as you see pictured on this screenshot. And then you have to give it the area below that upper critical value, which we've decided is 97.5% or 0.975, but also the t distribution depends upon its degrees of freedom. So we have to put a comma, which is right above the 7 on our calculator, and tell it the degrees of freedom, which is always n minus 1. And n is the number of observations. We have 12 of them, so our degrees of freedom is 12 minus 1, or 11. So we should go ahead and enter inverse t of 0.975, comma 11, and when we hit enter, it will give us that upper critical value as we see pictured in the following screenshot. So we can see our critical value is 2.201. So now we have all the necessary information to complete our confidence interval using the formula we displayed on the previous board. So the problem asks us to round to 2 decimal places. So our x bar is 2.36 plus or minus our critical value in this t-distribution. We have to go out 1.16 standard deviations above and below the mean to capture the middle 95%, times our s, which is 1.16, over square root n, which would be over square root 12. So we know we'll get a lower critical value by calculating the, using the formula and calculating the value by using the minus, and we'll get an upper critical value by using the plus. So if we type 2.36 minus 1.16 times, oops, I copied down the wrong critical value. Sorry, 2.20. Sorry, my goof. So our critical value is 2.20, and then times our 1.16 divided by square root 12. We should have a lower limit of our interval equal to 1.62. The upper limit of our interval can be found doing the very same thing, but instead doing 2.36 plus that margin of error. And when we do that, we get a upper limit of 3.10 when we round to 2 digits after the decimal point. So we can basically say that we are 95% confident that the grade point averages of all college students at this university is somewhere between 1.62 and 3.10.